Welcome, y'all. So today we're going to be solving Leetcode problem number 21, merge two sorted lists. So for this problem, we're going to be given the heads of two sorted lists, list 1 and list 2. And what our goal is to do is to take these two lists and all the numbers that are entail these linked lists and put them in order in another linked list. And it's also very important to note that these two lists are going to be sorted already, right? So if we look at an example right here, let's start right here. So linked list 1, we're going to have this node be 1. It's going to point to 2. And then this is going to point to 5. Now we're going to have linked list 2. We're going to have this one be 2. It's going to point to 3, which is going to point to 6. And then we're going to point to 7. All right. So practically, in this problem, there's a few ways to go about it. So technically, you could just grab all these numbers, right, and put them in an array. And this is not in order. We're just going by order of the linked lists, right, just like this. And we can just practically sort this. And then after it's sorted, we can just start from the left side of the list right here and just start creating our own linked list and go through it, right? But remember, if we sort the array like that, it's going to be in the time complexity of that's going to be in log n. And we can do better than that, right? And that's because this list that we have here, it's already sorted. So if you look at these linked lists, if we have this two-pointer method going on, when we're looking at one of the values in linked list 1 and one of the values in linked list 2, right? Like this, well, the lowest value or the head of the linked list that we're going to be returning is going to be one of these nodes no matter what, right? So practically, we're going to compare these two values right here. And we're going to see which one's lower. So linked list 1, node 1 right here, right? This is going to be the lower value. So for our return, we're going to want this node. This is going to be the starting node. And we're going to change our pointer and we're going to move it to the next portion of linked list 1. And now we're going to compare these two values, right? So what we're going to do is since they're equal in value, it doesn't matter which one we put first. So we're going to take linked list 2 and put this node right here as the next pointer. And now we're going to point these two to the next heads. So linked list 2 is now going to be at 3. And we're going to compare these values here. And linked list 1 has the lower value. So what we're going to do is we're going to take this node, put this next, and move the pointer to the next node. Now we're going to compare 3 and 5. So 3 is less, so now this is going to be the next one. We're going to have that pointer, we're going to move it to 6, and now we're going to compare 5 and 6, with 5 being the lesser one. Point to that, and now our pointer has nowhere to go. The only value it's going to point at is none. And when this is the case, when linked list 1 or linked list 2 is none, all we have to do is take the rest of the nodes from the non-empty linked list, and we're just going to add it on to the next, to the end of our return linked list. And now from this, we're able to get a linked, we're able to have our result And this is the one that we're going to want to return. All right, so now for the problem. So remember, we have the variable linked list 1 and the variable linked list 2. So before the variables that we're going to need for this problem, we're going to want to return a new linked list, right? That is going to be sorted. So we're going to have a head variable for the head of the linked list that we're returning. And we're also going to have another variable, which we can call current, for to be able to traverse the new linked list that we're creating that is merged already. So then we can add to it easily while still maintaining our head value. So we're going to have this list node. We're going to make it a dummy node. So it doesn't matter what this is named, right? Because we're just going to want to be able to use this node to add to our list. Because if we had another variable like none, well, there's no next attribute to it. So it's not going to work very well. We can do it, but it's unnecessary. So now what we're going to want to do is we're going to want to loop through these list 1 linked list and the linked list number 2 until one of these nodes or linked list becomes none. So while list 1 is not none and list 2 is not none. And once we're looking through these linked lists, like we have right here, if we had 1, 4, 6, 7, and we had another one that was 2, 5, 8, 9, and 10. So remember, we're going to be starting at the beginning of both of these linked lists, right? So we're going to want to see which value is smaller, right? So if list1.value is less than or equal to list2.value, well, that means we're going to want to add this to our new return linked list, right? So we're going to put this right here. And then in this case, right? So current.next is going to be equal to list1, right? So we're going to have this list be the next portion of our current, right? And our list 1 is not going to be list 1 anymore. We're going to want to take it from here. So we're going to want to go to this next node, to the next node, which is list 1 is equal to list1.next, right? And if this is not the case, let's say this was the case, well, now in this scenario, we're going to want to have our current.next equal to list2. And list2 is equal to list2.next, right? And after this, remember, when we're making our new linked list, right? Remember, we have the dummy. We're still going to be on this dummy for our current variable. So we're going to want to go to the next variable after adding to it. So current is equal to current.next. And now we're going to be at this variable. And now, after that, we're going to be able to successfully add the next value that's the least out of these cases. So after all this is done, right, we're going to get to the very end of this list, right? And this is going to be none. And we're going to have a 9, right? So because that one of the variables or one of the linked lists is going to be none, we're going to check which one that is. So in this case, if list 1 is none, what do we want to do? Well, since we're at the very end of our current values, right, for our return linked list, we want this next variable from this node right here, we want it to be 9, 10. So our current.next is going to be equal to list2, which is going to be this portion of the linked list. Otherwise, current.next is equal to list1. And now we're going to return our head node, since that head node is still at that dummy node. But we don't want to return the dummy node. So we're going to return head.next. So if we submit it, we can see right here that our solution does indeed work. And remember, for this case over here, if we had both linked lists as none as an edge case, right? It's going to pass through this while loop because they're both none. And it's going to see that, okay, list 1 is none, right? So now our current.next, right, which is the dummy node, our dummy node is going to want to point to none now. Because we say current.next, which is dummy, the next one's going to be none, which is list 1. And now when we return head.next, head is still on the dummy node. So it's going to return none in that case. And that's why it works with the edge cases as well. So that practically concludes everything. I hope y'all enjoyed the video, and I hope it helped you understand this problem more than you did before. And if you have any other problems that you want to go over, feel free to comment, and please like and subscribe.